An excellent experiment. The first of many steps is to grab 4 beakers and 4 beautiful eggs and fill said beakers with vinegar. You will want to fill the beakers up beyond the eggs just a bit so that the eggs are fully submerged in the vinegar. The point of the vinegar is to sort of dissolve the eggshells to make the next steps easier. Very well done, Ray. Next, you'll want to saran wrap these as Caleb is doing. Good work. Thumbs up. Yes, Ray, your nails are very pretty. Oh, looks like that one's a bit too small, Caleb, eh? Much better. It seems that some intense science is going on the tables behind us. Now, Caleb, don't get too distracted. After covering our 4 beakers, we shall place them in the science fridge. We will wait for 24 hours, and after that we get some very peculiar eggs. The first 3 had semi-hard shells, but the 4th one had a very soft feel to it. You're then going to want to partially remove the shells if they were not already removed in the first step. Whether you do this by hand or with some strange metal thing is up to you. You're going to measure the eggs. And put said measurements inside of this fabulous chart. Do some more measuring and some more charting. Next, you're going to want to grab some molasses and corn syrup. You're going to put an egg inside of one of the beakers. It seems another group was attracted by the noisome smell of the molasses. Now carefully pour the molasses into the beaker. Molasses is very dense and thick, as you can very clearly see. You want to grab another one of your eggs and place it inside of another beaker, and pour some corn syrup, as seen here. Now we attempted to fully submerge the egg, though it did float in the corn syrup, making it difficult to do so. Next, you're going to get some water and add some food coloring. Well done, Sadie. Place another egg softly and gently into the beaker. Then you're just going to get some plain water and place another egg inside of it. Now we cleaned up, and quite a bit too. We replaced some of the saran wrap and relabeled them. Great work, Nate. Your saran wrapping was better than Caleb's. we'll place the eggs back into the science fridge. Now we wait for 3 whole days, and after those 3 days, we came out with some very peculiar eggs, such as this one with a strange Mickey Mouse-esque protrusion that was soft, wibbly, and bouncy. The green egg had grown much larger and was very soft and bouncy, much akin to a bouncy ball. The corn syrup egg had seemed fairly the same, though it did collapse in on itself. And the same could be said about the egg placed in molasses. We will, after doing some thorough examination, we place the eggs back into the beakers. We'll then poke and stab the eggs to examine their insides. The egg that was put in water seemed fairly normal, though as expected the yolk was very watered down. The green egg had a lot of built-up pressure and sort of exploded out, but much like the water one, the yolk was fairly normal aside from being watered down. Well, this one was a little green. For all 4 eggs, the shell was very soft. For the egg placed in the corn syrup, everything seemed fairly normal, except for the fact that the yolk was a lot more solid than a normal one. The same could be said about the one in molasses, which was also fairly solid and rubbery, though this one more than the corn syrup. Very well done, scientists. Whoa, 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 whoa. Alright, that's interesting. You did the experiment, but what does it mean? Well, allow me to answer that question for you. You see, we were trying to show active/passive transport, as most people in this classroom are, and we chose to do it through eggs, as many other people are. And we did this because, as you could tell, the 4 liquids we chose were very easily separated into 2 groups. The first 2 were literally water and water plus some food coloring, and the second 2 were both very viscous, syrupy, and thick liquids. This was to show how passive transport works. You see, the first step was to get rid of the shell. That was so that we could get to the egg membrane, which is a semi-permeable surface. That means it lets things that are small enough through without using additional energy, which is passive transport. Now the 2 eggs that were in the water, you notice a very clear change in them. The green one was a lot bigger and clearly stuff went in there. Now, we can see that the water had to use passive transport to go from the high concentration around the egg in the beaker of water into a lower concentration into the egg, because there's not a lot of water in the egg. And then they kept switching out stuff until they were balanced out. That's why the egg got bigger. We also saw that the yolk itself was affected. The yolk of the eggs inside of the water was very clearly watered down, kind of gross. But for the stuff placed in the molasses and syrup, which are larger molecules than the water and couldn't fit through the semi-permeable membrane, we didn't see any increase in size, aside from, well, nothing, because it technically decreased in size because they kind of collapsed in on themselves. But we also saw that the yolks were fairly similar to how they should be normally. So here we can see that through passive transport, some things are let in and some things are not. That is the very simple explanation to our experiment. Thank you again for watching.